One of the big applications we're going to see of exponential functions is in the financial world when we start to talk about the notion of interest. Now, interest can be in the context of an investment. You invest some money, let's just say in a savings account. At the end of the year, you've suddenly got more money in the savings account because the bank has given you interest. They have paid you for the privilege of them getting to use your money during the course of the year because you've invested it with them. Interest also accumulates with debt, okay? So if you have student loans, once you start paying them back, you start accumulating debt on, you start accumulating interest on that. Generally, the interest is deferred while you're still a student. I hope that's the case. If you have a credit card and you don't pay it off in full at the end of each month, then they add on interest, so you owe a little bit more. Okay. Now, I realize you folks are students. You're probably more familiar with interest in the context of debt than you are in the context of investment. But I'm going to talk about it in the context of investment simply because that's the easier scenario. With an investment, if I just put some money down and it stays there and grows, that's all that's happening. The amount that I have is growing. With debt, you're generally required to make minimum payments. So the interest is causing your debt to grow, the payments are causing it to shrink. The formulas for calculating both of those things are more complicated. So we're going to focus just on the interest part, so I'm going to be talking mostly in the context of an investment. And what I want to do is just take a scenario. Let's say we invest $100 at 10% annual interest. I'm laughing here because that is not a realistic scenario. Okay, interest rates are going to be a lot lower. If you can find a bank that's going to give you 10% interest, tell me where. Okay, I'm choosing that just because I want to focus on the concepts. I don't want to get bogged down in tedious calculations. This is going to be easy to calculate. Okay, and I want to just compare what happens if I invest this with simple interest. Simple interest means that the interest is always going to be calculated based on that initial investment of $100. Compare that to compound interest. Compound interest, once I've earned some interest, I have more money. The next time I earn interest, I'm earning interest on that bigger amount. Okay? So let's go with a simple case of compound interest where we calculate the interest, we compound it just once a year. At the end of the year, based on what you had at the beginning of the year, we give you 10% of that. Okay, again, that's a little bit contrived, but we're just trying to understand the basic logistics, and then we'll get into some more realistic situations. Okay, so I'm going to just create a table with the year, okay, the interest from that year, so not the total interest, but just the interest earned in that particular year, and the value of the investment at the end of the year. We'll say time zero is when we make the investment. So year one, we're talking about at the end of that year. Okay, and I'm going to do this with simple interest here, and then I'll do it again down here for interest compounded annually. Okay, so after 1 year, we would have earned 10% of $100. That's $10. And so we would have $110. Okay, now that's going to be the same for my first year, even if I'm compounding the interest, because this is the first time we're calculating the interest. Okay. With simple interest, at the end of the second year, I get another $10 in interest. Every year I'm getting 10% of my original investment of $100, so I now have $120. And at the end of the third year, I'm going to get another $10 in interest, so I'm going to have $130. Okay, compound interest is going to be a little bit different, because at the end of the second year, I'm now earning 10% of my $110. So I'm going to be earning $11 of interest. Ooh, an extra dollar. I realize this seems insignificant. We'll talk about that in a moment. Okay, So now I'm going to have $121 at the end of that year instead. Now at the end of year 3, I'm earning 10% of my $121. So I'm going to be earning $12.10. Okay, so I'm earning, I've got a total now of $132.10. So this is better by $2.10. Now, that's not a huge difference, but compound interest is a huge deal. It does make a big difference. Couple of things that will make it a bigger deal. One might be larger amounts of money. If you ever buy a home, homes are expensive, okay? Paying interest on that, often people end up paying more money in interest than the actual price of the home, okay? It can be that big of a deal, okay? Another thing with home buying, this also occurs, it's over a longer period of time. This was just a period of 3 years, okay? So more money, more time, it's going to start to be a bigger deal. The other thing is, we only calculated interest once a year. Here we were compounding annually. That's actually not usually what's done. Usually you would compound more often. So if we compounded interest at the end of every month, then that's more often that the amount that we're basing the interest on has gone up. That's going to start to increase things. So the number of times that we compound the interest will go up. Will make the compounding a bigger deal. Okay. So what I want to do is just see if we can't figure out the formulas for these things. I'm going to start with just simple interest. We'll get the formulas for that. Then I'm going to start with interest compounded annually. See if we can just sort of figure that out based on this example. And then we'll adjust that model for what if we wanted to compound it more frequently, which is a much more realistic thing. Okay, so let's introduce some notation that we'll use in both of these scenarios. So P is going to be the principal. That's just a fancy word for the amount that's invested. So that's the initial amount. In our example, that was the $100. Okay. T is going to be time in years. So time 0, that's going to be when we make the investment. When time is 1, that's 1 year later. Okay. R is going to be our interest rate. And let me specify, it's the annual interest rate. And it's going to be as a decimal. Okay. So it's usually going to be given to us as a percent. I said 10%, but in that problem, R would have been 0.10, not 10. In all the formulas, when you're working with a percent in math, you always convert it to a decimal before you plug into any formulas. Okay, I can be the interest, and A is going to be the value of the investment. I'm matching the notation in the book. You might say, why don't we use a V for value? Well, A is the second letter. You can also think of that as the amount that the investment is worth. Okay, now for simple interest, the interest is just the principal times the rate times the time. Okay, so when our time was 1, we had, 100 times the 10% written as a decimal times 1 gave us $10. When time was 2, we would have had 100 times 0.10 times 2, 20. Okay. Now, we didn't earn $20 that second year. That 20 would be the total interest we had earned over those 2 years. Okay. And basically, we're just going to get $10 a year on that particular model. Okay. And then the value of the investment is just the principal plus the interest. So after 2 years, I'd earned $20. I had $100 plus $20 or $120 in the bank. Okay, so that's our simple interest. The book doesn't explicitly state this formula. It's sort of common sense. The total amount that you have is the investment plus the interest. So I think it's worth writing down, but I do want to point out that it's not explicitly stated in the textbook. Okay. Now I want to try to come up with the formula for the compound interest. I'm going to erase this just so I have some more space. Let us see if we can figure it out from this example. Okay, so at year 1, the amount that we had in the bank at the end, we had the $100 plus 10% of the $100, okay, because we hadn't compounded our interest yet, okay. And notice that 100 occurs in both of those terms. So if I wanted to, I could factor that out and say that's 100 times 1 plus 0.10. Okay. Now I'm purposely writing it this way. Obviously I know that that's 1.1, okay? But I'm purposely writing it this way because, well, keep watching. Okay, at year 2, I'm calculating now, the amount that the investment is worth at the end of that year. It would be what I started with, which is this. This is the value at the beginning of that year. So 100 times 1 plus 0.10, okay, plus I would have earned 10% of that. So 0.10 times 100 times 1 plus 0.10. Now, this right there, that 100 times 1 plus 0.10, that was the value at the end of the previous year. Notice that shows up in both terms. So if I wanted to, I could factor that out. So I could say this is 100 times 1 plus 0.10, and then what's that multiplied by? Well, if I factor that out, that's factoring out everything here, so that's going to give me 1 plus, here I was multiplying it by 0.10. So this is just saying that's what I had after 1 year. At the end of the second year, I'm going to have 1 copy of that. I'm still going to have my original amount of money plus the interest, 0.10. Okay. But notice then, that's the same as 100 times 1 plus 0.10 squared. Okay. Now, after the third year, okay, this is what I had at the end of the second year. So at the end of the third year, I'm going to have this plus the interest I earned. So I'm going to have 100 times 1 plus 0.10 squared plus the interest, which is 10% of 100 times 1 plus 0.10 squared. Okay. But if I look, that amount that I had at the end of 2 years shows up in both terms. I could factor that out. So I could say that's 100 times 1 plus 0.10 squared. What's that multiplied by? Here it's being multiplied by 1. Here it's being multiplied by 0.10. And so that becomes 100 times 1 plus 0.10 cubed. Okay, so this video has been going for a little while. I'm going to end this video here. We'll summarize this result and then modify for what if we're compounding more often than just at the end of every year in the next video.